Okay, so this is the last part of chapter 1, and in this part, we study the difference between joint distribution and marginal distribution. So, from the previous example, we considered female and health insurance as two variables of interest. So, then you can think about their joint distribution. So, joint distribution is literally probability distribution uh, concerning about both of the variables, right? So, you can look at them from different uh, angles. You may calculate probability of female having a health insurance or probability of male not having a health insurance. So that's joint distribution. Literally is about both, but marginal probability is about a single variable. So you can also think about before I introduce the 2 by 2 example, I considered health insurance variable alone. In that example, it was about single variable, and you can imagine the probability distribution for health insurance alone, and also you can think about another probability distribution for gender alone. So you can think about probability distribution for a single variable, and then we call that marginal probability. But you can define marginal probability for each of the variables. And then what we are going to study here is that marginal distributions, you may think it this way. Joint distribution is about two variables, and when there are two variables, you can also think about two marginal distributions for each of the variables, like probability of female and probability of having a health insurance for each of the variables. But the conclusion is that these probabilities are not complete. So from this information, you cannot recover the full probability. That's the key observation, the conclusion in this part. So think about this. We made this table, 2 by 2 table, and also you can easily calculate their sum, right? So sum across these two, within this column, and you get 50%, which is the probability of female. And if you sum across columns, you get 33%, which is the probability for not covered. So this column, summation across columns, will become the marginal distribution for health insurance, right? So this part becomes another marginal distribution for health insurance, right? In this table, gender disappears. Gender is integrated out. It's filtered out by summing out, it's summed out. So this is the joint distribution, and this is a marginal distribution. We just learned how to convert a joint distribution into a marginal distribution. You can do the same thing for gender, right? Like for example, use these numbers to calculate another probability distribution for gender. Remember, this is different probability table from this guy. It is health insurance. It is gender. Numbers are different. So from a joint distribution, you can make two marginal distribution for each variable. It is also possible even if you have more than two variables. If you have three or more variables, still you can calculate the marginal distribution for each variable. That is not a problem at all. It is just a matter of summation, right? However, can we go the other way? Suppose that we have two marginal distributions for gender and for health insurance. Can we go back and make a 2x2 table? The answer is no. That's the point here. So these two tables cannot recover the full distribution. So for example, like so for example, you want to calculate, we have these two tables or same information here. We have this information, probability for health insurance and probability for female. And from this, can you calculate the probability of female without health insurance? Try or think about it. How can you calculate that? I gave you probability of not having health insurance and probability of female. Then can you calculate probability of female and not having health insurance? The answer is no. Why? So I'll give you two examples. So first one is what we saw like from the data. This is the true distribution from the data, but I made up a fake table. Like extreme case, suppose that there is 0% this type. Still, there is no problem. You can make up the same marginal distributions. Using 0 here, just change the numbers, the other numbers accordingly. Then you can have the same marginal distributions. So this part, numbers here, same. Numbers here, the same. So that means if you observe the marginal distributions, you cannot guess what's the truth. So, we know this is true because we already know the we already saw the data. But without looking at the data, this can be possible, right? So, also these numbers are consistent with those marginal distributions. So you cannot recover the full joint distribution. You don't know what is wrong, what is right. That's the problem. And to see this better, let's think about this problem in general. What we want is 2x2 table. There are 4 unknowns, x, y, z, w. There are 4 possible outcomes. So what we want is 4 probabilities. So we put them, we denote them using 4 letters. They are unknowns. We would like to solve for these 4 unknowns. And the information we have is the probability of not having health insurance is 33.69%. And the probability of female, x plus z, is 50.52%. So this is our information, 2 equations, and there are 4 unknowns. We cannot solve them. This is a simple principle, the reason why marginal distributions cannot recover the joint distribution. Also, if you increase the number of variables, this problem becomes more severe, right? The difference between number of equations and the number of unknowns will increase as the number of variables increase. Now then, let's see, we add another information. So the first 2 informations are the same as before. And now I told you, I give you another hint. 19.89% are men without health insurance. Then from these 3 information, can you calculate the probability of female without health insurance? Think about this problem. Maybe the additional information can help or not. If yes, try yourself. What is that probability? And okay, so let me give you the answer. The answer is yes. Yes is the answer. And we will look at the same problem this way. there are 4 unknowns and there are 3 informations. So the last one is the additional information. Why? The probability of male without health insurance equals 19.89%. This is the additional insurance. Like, it's reasonable if you find that there are 3 equations for 4 unknowns. So if you answered no because of that, you did really well. But there is one hidden information I didn't tell you. That's this. So we are handling probabilities. So any probability should satisfy this equation. So this is a hidden information that I did not explicitly told you. So the sum of 4 unknowns must be 100%. So combining 1, 2, 3, and 4 equations, you should be able to solve for these 4 unknowns. And I believe it should be straightforward. Given that the prerequisite is calculus, solving out this equation should not be a problem. And in the end, you will get x equals 13%, z equals 36%, w equals like this. So from each equation, you get y, x, z, w. So we recover the full joint distribution. And again, the conclusion is that marginal distributions are not complete. You need additional information to obtain the joint distribution. That's what you need to understand in this chapter. Okay, this is end of chapter 1. So please go try homework 1 and see you in chapter 2. See you later.